Now this one's just a little different, so it's a radical. So if I look at this guy, we're going to have the square root of, take the x out, put in x plus h, so this is really the square root of x plus h plus 5. The original function is the square root of x plus 5. Now take the first plus h plus 5, subtract the square root of x plus 5. Cannot do anything with that. So this is now the square root of x plus h plus 5, subtract the square root of x plus 5 all over h. Now again, if I were to let h equal 0, I'd have a 0 over 0 form, and then that says algebra. Well, the algebra is exactly what we did with something like this with radicals. I need to use the conjugate. So I'm going to multiply the numerator by the square root of x plus h plus 5 plus the square root of x plus 5. The square root of x plus h plus 5. The square root of x plus 5. Ultimately, that h has to go away. So radical times radical eliminates the radical. Inner and outers add to 0. Radical times radical, but that's more than one term, so it comes out in parentheses. All over h times the square root of x plus h plus 5 plus the square root of x plus 5. This equals x plus h plus 5. Subtract x, subtract 5, all over h times the square root of x plus h plus 5, add the square root of x plus 5. Plus x minus x plus x minus 5 plus 5. There's h all by his lonesome, of h times the square root of x plus h plus 5 plus the square root of x plus 5. The h's reduce out. So this is 1 over the square root of x plus h plus 5 plus the square root of x plus 5. And now I can let h go to 0, and it works just fine. So this is all the algebra part of a calculus problem.